Now let's consider again what we noticed when we did these graphs, that the graph of x minus 1 quantity squared appeared to be just a copy of the y equals x squared graph, shifted 1 unit to the right. The purple graph appears to be very much the same as the green graph, but shifted 1 unit to the right. It would seem that x minus 1 with a minus would be shifted 1 unit to the left, wouldn't it? Well, let's see why it shifts 1 unit to the right. We just make a table of y equals x squared, y equals quantity x minus 1 squared for negative 2, negative 1, 0, 1, 2, 3. I didn't put the 1/2s in there because they kind of mess up the pattern that we're going to see. Okay. Well, let's see. It looks like the same x values occur over here. The 4, 1, 0, 1, 4 sequence of x values occur here as occur here. But it looks like they occur here 1 unit earlier than they occur here. So to get the same value of the y equals x minus 1 squared function, you would have to let x be 1 unit greater. So that the points, we'd have negative 2, 4 up through 2, 4. Here we'd have negative 1, 4 up through 3, 4. All these points would lie 1 unit to the right on the graph. And we'll draw the graph and make that really clear. So here's our graph. I'm not going to bother marking the axis off, but let's draw the points for the y equals x squared function in green and the points for the x minus 1 squared function in orange. Okay, we have the point negative 2, 4. Well, I'm going to say, okay, negative 2 is here and 4 is going to be here. Then we have negative 1, 1. Well, negative 1 is going to be twice as close to the origin, and 1 is going to only be 1/4 as high as 4, so the point might look like this. Then 0, 0, no brainer where that goes. And then 1, 1, well, 1, 1 is just a reflection of this point by the symmetry of this function. We've done the symmetry test on it. We see the symmetry, and of course we can see the symmetry from the table. So we can go out here to 2 and get the point 2, 4, and then we sketch our curve. Okay, now let's try the values for the y equals x minus 1 squared function. Now we could do negative 2, 9, but I'm not going to draw that one. It's going to be up pretty high. We'll do negative 1, 4. Where's negative 1, 4? Well, negative 1 is here, and 4 is up here. And what about 0, 1? Well, 0 is here in the x-axis, and the y value 1 is right here. What about the point 1, 0? Well, 1 on the x-axis is here, and 0, of course, for the y value puts us on the x-axis. And then we have 2, 1. So let's see, 2 is out here, and 1 would be up here. And then we have 3, 4. So 3 is here, and 4 is here. And it appears pretty clear that each of these points is 1 unit to the right of the corresponding point on the green graph. So, we move 1 unit to the right here, 1 unit to the right here, a unit to the right, a unit to the right, and a unit to the right. And we get the points on our orange graph representing the x minus 1 squared function. And if we draw the graph, it's very plausible that this whole graph is shifted 1 unit to the right from the y equals x squared function. So we have y equals x minus 1 quantity squared, and we have y equals x squared, and the y equals x minus 1 quantity squared graph is shifted 1 unit to the right of the y equals x squared graph. And again, the reason is simply that not that minus 1 shifts us 1 unit in the negative direction. It's because of the minus 1, x has to be 1 unit bigger in order to give you the same y value. So hopefully that'll make some sense to you. That is the rule. You've got to remember the rule, but it's easiest to remember the rule if you remember the reason for it.